In this video we are going to explain how to solve series and parallel circuit. This first one is a series circuit, as we can see in this image. The electrons only have one way, so the electrons that goes from the negative to the positive pole of the battery, all of them will have to pass through all the resistance. That's the reason because of it is a series circuit. So since it is a series circuit, we will have to apply these formulas. These are the formulas of the magnitudes for series circuit, and this is the Ohm's law. The Ohm's law will be applied the same in any kind of circuit, but depending on the kind of circuit, if it is series, parallel or mixed, we will have to apply these formulas here or others that we will see later. So in series circuit, since the electrons have to pass through all the resistance, they will lose part of their strength, of their voltage, on each of the resistance. That's the reason because of all the total voltage is equal to to add up all the voltage. At the same time, since the electrons all go through the same way, we will have always the same number of electrons in any part of the circuit. Because of that, we can see that all the intensities, the intensity that pass through resistance 1, resistance 2, 3 and 4, all of them are the same and are equal to the total. So we are going to use all these formulas to find all the information we need. We have the total voltage and the partial resistance. So we need the other information. The first thing we are going to do is to find the total resistance. Since we have all the partial resistance, we can apply this formula here. So just sum up all the resistance and we will have the total resistance, which is 256 ohms. We see 37 plus 58 plus 29 plus 132. You can do this with your calculator. Is equal to 256 ohms. So now that we have the total resistance, the next thing will be to find total intensity. Since we have total voltage and total resistance, we can apply the Ohm's law. Always remember that we can apply the Ohm's law if we have total voltage and total resistance, or for example voltage 2 or resistance 2, voltage 4, resistance 4, or in other cases if we have resistance and intensity. But we will have to use these formulas, but always with the same resistance. We cannot calculate any of them with, for example, resistance 1 and intensity 3. It has to be resistance 1 and intensity 1. So since we have total voltage and total resistance, we calculate total intensity by dividing the total voltage between total voltage divided by total resistance, which is 5.12 divided by 256, and that's equal to 0.02 amperes. And now that we have the total intensity, we will look again at the formulas for the series circuit, because with the total intensity we will know that all the intensities will be the same. So intensity 1, 2, 3 and 4, all of them will be equal to total intensity, which is 0.02 amperes. And finally, since we have all the intensities and all the resistance, we can apply the Ohm's law for the voltage for each one of the voltage. So voltage 1 is equal to resistance 1 multiplied by intensity 1, which is 0.74, and we do the same with all the other voltage. So with that we will have the total voltage. With that the exercise will be complete. But if we want to make sure that we haven't made any mistakes, we can look again at the formulas here of the series circuit, the formulas for the voltage, and we see that the total voltage is equal to the addition of all the voltage. So we are going to try to sum up voltage 1, 2, 3 and 4, and if the result is equal to total voltage, the exercise will be correct. So if you try to sum up all of this, the result is equal to 5.12 volts, which is the same as the total voltage. That will help us to be sure that we didn't make any mistakes. Now let's go with a parallel circuit. We know that this one is a parallel circuit because there are different ways, so some of the electrons will pass through this resistance and then go back to the battery, others will go through this other, and the same for all of them. So the electrons will divide, and they will take different ways to pass through our resistance and then go back to the battery. So these are the formulas for the parallel circuit, and the Ohm's law that is applied the same for parallel, series or mixed circuit. As we can see, this time all the voltages are the same, while the intensity is made by the addition of all the intensities. That's because since the electrons that pass through this battery, through this resistance, only pass through this one and then go back to the battery, to the other pole of the battery, they will lose all their strength on each one on the resistance they pass. Instead of passing through all of them and lose part of their voltage in each one, they only pass through one and lose all the voltage in that one. That's the reason, because of all the voltage are the same in parallel circuit. On the other hand, the intensity will be different, because since the electrons go through different ways, we won't have the same number of electrons here at the beginning of the circuit or at the end as we will have in this resistance or in this other. If all the resistance have the same value, the number of electrons on each resistance will be the same, but that's not the case in this circuit. And the formula for the total resistance, we see that it's also different. The inverse of the total resistance is equal to adding up all the inverse. Once we have the inverse of the total resistance, we have to do the inverse again, and we can find the total resistance that way. So in this circuit, with this information, we will have two different ways to proceed. One will be to find the total resistance, since we have all the partial resistance, and the other way will be, since we have the total voltage, we will know the values of all the voltage. I'm going to do this way, to start with the voltage, because I think it's easier, but at the end of the video I will show you also how to do it with how to find first the total resistance. So as we said, since all the voltage are the same, all the voltage 1, 2, 3 and 4, all of them will be 10 volts. And since we have all the partial voltage and all the partial resistance, we can apply the Ohm's law to find all the partial intensities. We will have to divide the voltage divided by resistance, so 10, which is voltage 1, divided by resistance 1, which is 200, equal to 0.05. The same with intensity 2. Intensity 2 is 10 divided by 250, which is resistance 2, and again with the other, and these are all the results. So with that, I will have all the partial intensities. After that, I will use again the formula. I will use this information and the formulas for the parallel circuit. Now that I have all the partial intensities, I can just try to sum up all these intensities to find the total intensity. So intensity 1 plus intensity 2 plus intensity 3 plus intensity 4, 0.05 plus 0.04 plus 0.01 plus 0.1 equal to 0.2 amperes. So the total intensity will be 0.2 amperes. And the last part will be to find the total resistance. Since I have total intensity and total voltage, I can find total resistance with the Ohm's law. So I will make voltage divided by intensity, total voltage divided by total intensity, 10 divided by 0.02 equal to 50 ohm. But now, to make sure that I haven't made any mistake, I'm going to calculate again the total resistance, but now using this formula. if the result is the same as this one, that will help me to make sure that the exercise is correct. So if I try to add this to do this formula, 1 divided by total resistance equal to 1 divided 200 plus 1 divided 250 plus 1 divided 200 plus 1 divided 1000 plus 1 divided 100. I see there are all of this resistance, but the inverse, 1 divided the resistance. So to sum up fractions with different denominators, I will have to find the lowest common multiple of all of them. In this case, that number would be 1000, to make equivalent fraction with the same denominator. So 200 to get to 100 to 1000, I have to multiply by 5. 250 I will have to multiply by 4. From 1000 I don't have to multiply, so it remains as 1. And from 100 I will have to multiply by 10. So it's 5 plus 4 plus 1 plus 10, all of that divided by 1000. That's equal to 20 divided by 1000. But that's not the total resistance, that's the inverse of the total resistance. We have here that it is 1 divided by total resistance. So to find the total resistance, I will have to turn this fraction upside down. Instead of 20 divided 1000 is 1000 divided by 20, and the result is equal to 50 ohms. I can see that it is the same result this way as this other. So with that, I'm sure that all the exercise is correct. So that would be the end of this video.